Hello, beautiful people, and welcome. In today's video, we are talking about how to graph square roots. Now, as always, I am human, so if I make a mistake, please let me know where the mistake occurs so that way I may learn from it. All right, so let's talk about a parent function of a square root. The parent function will look like either y or f of x is equal to a square root of x. Now, if we include some sort of transformation in that, you get two different equations. Now, the reason there's two of them is because with the property of a radical, we can sometimes absorb this b value and create it into an a value. And we'll do an example here in just a minute. So with your transformations, you have the traditional transformations. Your k value is going to be your up or down shift. Your h value is going to be your opposite of what you see. And that is going to be your right or your left. Your a value is your vertical stretch or compressions. And then your b value is, again, opposite of what you see because it is inside the function. And that is your horizontal stretch or compression. So just like you've been used to all of your H's and K's and B's and A's, exactly the same thing, that doesn't change. Now, the first way to graph a square root is by looking at the parent function values. For a square root, we have 2 points that are your reference points. Typically, there are more than that. However, there is an excluded chunk that is in the square root function. So let's take a look at these 2 points on a graph. So we have 0 and 0, and we have 1 and 1. The next point that we have, let's do a little t-chart. We have x and y, so we got 0, 0, we got 1 and 1. If you plug in a 2 into your parent function, so let's write out our parent function. Our parent function is just the square root of x. If we plug in a 2, well, what's the square root of 2? That's not a pretty number. We don't like that. So I'm going to remove 2 and say, hey, I don't want 2. What about 3? What's the square root of 3? If I put 3 here, can we take the square root of 3? No, that's an icky number. What about 4? If we take the square root of 4, well, we know what that is. That is 2. So here's 1, 2, 3, 4. Square root of 4 is 2. Now, what happens if we go the other direction? What happens if we take a negative 1? Well, the square root of a negative 1 doesn't exist. So if you're in my class, if you're in Integrated Math 3, this is something you learned in Integrated Math 2, that a negative 1 square root, it actually means an imaginary number. So we're not dealing that. We want to deal with pretty numbers, whole numbers, stuff that we can graph. So this is an excluded. But what about negative 2 or any other negative number? Well, you cannot take a square root of a negative number. These are all going to be excluded. These are not part of it. So that means we have a limited domain where domain is the set of all x's such that x is greater or equal to 0. It cannot be less than 0 because we can't take a square root of a negative number. So that means we are going to stretch this out exponentially, but only do it towards the positives. Now, there could be in our transformation a reflection across the x-axis. There could be a reflection across the y-axis. So this curve, this half curve, could be going to the right, could be going towards the left, could be flipped over the x-axis, going to the right, to the left. So all of that could happen, but this right here is your parent function. So let's talk about the transformations that could occur. So if you have transformations, your original parent function point of 0, 0 becomes your h and k. So that's going to be your endpoint or your starting point, depending on how you want to look at this butt right here. So we have your h comma k, so it doesn't matter which formula. Now, depending on whether you have a horizontal stretch or compression, or if you have a vertical stretch or compression, these formulas change. So you have an h plus 1 where you take h is opposite of what you see. You have an h plus b where you take your b value. Now, I personally, even though this right here seems really straightforward, you have your 2 points, you plot them, you're done. I personally don't like that method because I don't want to memorize any sort of formula. So when I do it a different way. Now, if you're in my class, you can choose to memorize this and just, that's it, that's your method, memorize it, plug the numbers into your formulas, and you're done. I, however, will recommend that you use the pretty point method, which is the method that we use when we were graphing cubics. Same exact method. So step number 1 is, well, let's take a look at our parent function. Our parent function is y equals the square root of x. Here are your reference points. Now, realistically, you don't need this third point. You only technically need 2. I am going to be, for the sake of this example, giving you that extra example with the 4 input and the 2. However, for you, you only need to do 2. So here's your example. Step number 1 is you're going to take this input, this highlighted x minus 1. It doesn't matter what is inside, you just take whatever's inside. You're going to set it equal to your original parent function x value. So I'm going to set it to 0, I'm going to set it to 1, and I'm going to set it to 4. When you're doing that, you are solving for the x value that makes the equation equal to 0, that makes the equation equal to 1, and that makes the equation equal to 4. Why do we want 0, 1, and 4? Because those are pretty numbers that we can take the square root of. So I'm going to subtract 1, subtract 1. My new x value is negative 1. I'm going to add 1. I'm going to add 1. Oh, did I subtract? Oh, I'm sorry. That should be an add. So I'm going to add 1. So this x value is a positive 1. This x value is a 2. I'm going to add 1, and this x value is a 5. Now, the x's that you just solved for need to be plugged into the original equation. Now, in my class, I did teach you a way to cheat a little bit and skip that step because we know that this x plus 1, when x is 0, is, excuse me, let me try that again. We know that x minus 1 inside the radical will be 0 when x is 1. So we're going to take this x is 1, we're going to plug it in. So we got 4 times the square root of 1 minus 1 minus 4. And you're going to solve for your y. This part right here, let me grab another color. This part right here will always equal your original parent function value. It just comes back from where you came from. So you came from a 0 here. This part that's highlighted in orange will be a 0. So if this right here came from a 1, that section that I just highlighted will be a 1. This part right here came from a 4, so this part will be a 4. You can continue to plug in your x's and solve. However, you can skip that step if you want. You don't have to do that. So I'm just going to write it out for those of you who do want to know where your x's are going. So we got 4 times 0 minus 4, 4 times the square root. I'm doing this one on purpose for 1 minus 4. That means 4 times 1 minus 4. Make sure you're recalling your PEMDAS. Multiplication before you subtract. So we got 4 minus 4. So that means this is 0. I never finished this one. This is 0 minus 4. So we got negative 4 is equal to y. This is y is equal to 0. And we have 4 times the square root of 4 minus 4. Square root of 4 is 2. 4 times 2 is 8. 8 minus 4 is a positive 4. So what does that look like? What does that mean in our graphing world? So I'm going to shift this up just a little bit. So our parent function reference points was 0, 1, 4. Now our transformed points for y equals 4 times the square root of x minus 1 minus 4. Grab a different color. We had an input of 1. We had an output of negative 4. We had an input of 2. We had an output of 0. We had an input of 5. We had an output of 4. If you keep track of your endpoint, then you know which point, once you've transformed it, is going to be your new endpoint. You also can do a mental check. If you plug in 0 into x, 0 minus 1 is a negative 1. We can't take a square root of a negative number. So that means 1 is going to be your lowest number that you can plug into your equation. Let's go ahead and sketch this out. Doesn't have to be perfect, just a rough sketch. We got 1 and negative 4. Here's 1, here's 1, 2, 3, 4. Here's 2 and 0. And then here's 5 and 4. 1, 2, 3, 4. So we are looking something like that. Looking at that 4 out in front, that is a vertical stretch by a factor of 4. So this being stretched that way should make sense based off of your equation. Let's go ahead and do one more example really quick. I'm going to skip this one. I'm going to do this one right here so we can see a difference with a horizontal stretch or compression. This would be a stretch. Take all of your inside, and you're going to set that equal to a 0 and a 1. Now, in the previous example, I did do a 4. We're just going to leave that out. It doesn't really matter. We just need 2 points because we want a rough sketch. We don't want an exact. We don't want to be wasting our time with too many points. I'm going to multiply by 3. So I get x plus 2 is equal to 0. X plus 2 is equal to 3. I'm going to subtract 2. X is then equal to 1. And subtract 2. X is then equal to a negative 2. Once we have here, we're going to plug that back into the equation and solve. Now again, you can skip this step by taking what you originally started with, but I'm finding that you guys like the plugging back in step, so we're going to do that. It's okay, so negative 2 plus 2, well, that's 0. So I got 1/3 times 0 square rooted minus 1. Well, 0 times anything is 0, so we have, oh, sorry about that. So we have square root of 0 minus 1. Well, square root of 0 is just 0 minus 1, so that means our y value is negative 1. Let's do it again. I have 1/3 times 2 plus 1 is 3. 1/3 times 3 is 3 over 1. So that means we have square root of 1. Square root of 1 is just 1. 1 plus 1 is 2. That means our y value is 2. So how does that look like when we sketch this out, when we graph? Let's do that really quick. Let me shift this up. Do a little t-chart. Here's x, here's y. We have 0, 0, and 1 as our parent function, square root of x. Our transformed function looked like the square root of 1/3 times x plus 2 plus 1 is equal to f of x. We had 2 points that were transformed from the parent function. One of them was, I'm going to look back here, negative 2 and negative 1. And then we had 1 and 2. So when we graph this, when we sketch this out, grab it. Oops, sorry about that. When we sketch this out, we have negative 2 and negative 1. We have 1 and 2. Again, pay attention. Your transform point, your 0, 0, became negative 2 and negative 1. So this is your endpoint. So that means you're going to be curving. Now, if you wish to find your x-intercept and your y-intercept to know where they cross, go ahead and set your values equal to 0 and solve. I'm just going to do a rough sketch and say that is what we have. All right, beautiful people, thank you so much for watching. We'll do more examples in class. Bye.